Now, exercise. So binomial theorem is very useful. Okay. Just take a look of these examples. Okay, exercise 1. So what is the expansion of this x plus y to the power 4? So if you understand what is going on, then this will be about 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, 4 choose 4. So this will be x to the power 4 plus 4x3y plus 6x squared y squared plus 4xy cubed plus y to the power 4. So I get this because I'm checking the fourth row of this Pascal triangle, 1, 4, 6, 4, 1. So these are the binomial terms for the corresponding. So we set the coefficient as the corresponding binomial terms. Is that okay? And then how about this one? Exercise, let's say 2. Okay. We want to find out what is the coefficient of x to the power 12 in this one, 2x minus 3y to the power 25. Eh? Let's forget this y. Okay. Yeah, so what is the coefficient of x to the power 12 in this one? So this will be equal to what? So you need somehow x to appear exactly 12 times, right? And the remaining term to appear exactly 13 times. Is that okay? So there are altogether 25 terms there. And then you want this x to appear exactly 12 times, or this one to appear exactly 13 times. So it is 25 choose 12. This is the coefficient. But then when x appear 12 times, then you will have 2 to the power 12 multiplied. Is that okay? And when this minus 3 appears 13 times, you will have minus 3 appearing 13 times. Is that okay? Yeah, maybe I'm wrong. Yeah, but it looks like the logic is correct. Okay? So you want to find out how many ways, what is the coefficient of x to the power 12? So you first should know that how many times this part should appear and how many times this part should appear. So I'm going to select 2x exactly 12 times. So among 25 terms, 2x is selected 12 times. So 25 choose 12 ways to select which one we should include 2x. Okay. Now whenever we include 2x, then there will be 2 to the power 12 when there is 2 there. Is that okay? And all the remaining terms, they are minus 3, so there is minus 3 to the power 13. If you are okay with this so far, could you please raise your hand? Okay, good. And now, let's do some simple counting. Sum. So if we sum everything in the same row, what will we get? So if you sum 1, it is 1. Is that okay? 1 plus 1 is equal to 2, so we get a 2. 1 plus 2 plus 1 is equal to 4, right? 1, 2, 1, 4. We get a 4. 1, 3, 3, 1, 8. 1, 4, 6, 4, 1, 16. Is that okay? 1, 5, 10, 10, 5, 1. If you believe me, it will be 32. So what we are saying? So here we are saying that, so exercise 3 is, we want to find out if you sum all the terms in the same row. So sum all the terms in the same row. So it is r is equal to 0 up to n. N choose r. We want to show that it is equal to a 2 power. This is exactly equal to 2 to the power n. Is that okay? Right? Is it x? Yeah, to the power n. Why? 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 Yeah, why?
If you can think like x plus 1 and power n, and when you x equal to 1.
Okay, excellent. Okay, very good. Excellent. So his idea is, let's apply this binomial theorem. You set x and y to be 1. What do you get? The left-hand side is 1 plus 1 to the power n. Am I correct? So the left-hand side is 2 to the power n. How about the right-hand side? The right-hand side is what we want. This is the summation of every term, n choose r. Yeah, when x and y are equal to 1, the right-hand side is equal to the summation of n choose r, all the cases. So we get it. Is that okay? Just set x and y to be both 1. Okay, now if you are okay with this, let's take a look of another case. Okay. Okay, so this time, okay, so the first one is 1. Okay, this is an exception. The next time, we want every term here, alternating term with the minus 1. So this will be 1 minus 3 plus 3 minus 1. 1 minus 4 plus 6 minus 4 plus 1. Is that okay? So you get a minus for every second term. We want to add them together. So what will we have? So this is 1 minus 1. You get a 0. Is that okay? And then 1 minus 2 plus 1. It is equal to 0. Okay? 1 minus 3 plus 3 minus 1. So it is symmetric, right? You have a 1 here, minus 1 here. You have 3 here, minus 3 here. So it must be 0. Is that okay? 1 minus 4 plus 6 minus 4, 1. 0. Okay. So how do you get this? So we want the other one is, you want to have summation of what? N choose r times minus 1 to the power r. For r equals to 0 up to n, we want to show that it is equal to 0 when n is greater than or equal to 1. Okay? Why? Why is it true? And this is also very simple, okay? This is to do what? This is to do, we set x to be 1, we set y to be minus 1. We get exactly the same thing here. Is that okay? So on the left-hand side, it will be 0 to the power n. On the right-hand side, it will be the same term that we have here. Is that okay? So this is it. Okay? One more, the last example. Okay. Yeah, the last example. So why do we need n to be greater than or equal to 1? So you see that from the equation on that side, the first one is not okay. Okay, 1 is equal to 1. You don't have a 0 here. There's an exception here. This exception, this term is 0 choose 0. This is a special term. We set it to be 1. The exception is actually coming from that. 1 minus 1 is equal to 0. But 0 to the power 0 is not defined. So you could think of this as 0. You could also think of this as 1. Is that okay? If 0 to the power 0, if the bottom part looks more like 0, then it is 0. If the top part looks more like 0, and then it is 1. Is that okay? So 0.01 to the power 0, it is 1. 0 to the power 0.001, it is 0. Is that okay? So it depends on which one looks more like 0. So it is undefined if I just tell you 0 to the power 0. So for this equation to work, we don't include the case where n is equal to 0. We start from n is equal to 1. Okay? Okay, one more exercise. So this is so this exercise. So the last one is, this term you're going to multiply this with 2. For every second term, you're going to multiply this with 2. For every next term, you are going to multiply this with 4. For every third term, you are going to multiply this with 8. and then this is going to multiply this with 16. And you want to find out what is the sum of them. Okay, let's do the summing. So this is equal to 1, am I correct? 1 plus 1 times 2 is equal to 3, very good. 1 plus 4 plus 4 is equal to 9. Okay, so this adds up to 9. Is that okay? And how about this one? 1 plus 6 plus 12 plus 8. 1, 6, 12, 8. 1, 6, 12, 8. 27. Very good, 27. And you guess it. So before doing the counting, 1, 3, 9, 27, this should be 81. So let's do the checking. So this is 1, this is 8, this is 24, this is 32, and this is 16, right? These two adds up to 40. These three adds up to 72, 80, 81. Is that okay? So this is 81. Okay, so we want to show that this is in turn equal to 3 to the power n. So how do we get it? So we're asking what? We're asking this one, instead of having minus 1, we multiply this with 2 to the power r. Is that okay? And then this will be what? This will be what? Using the binomial theorem, it is equal to 1 plus 2 to the power n. So it is equal to 3 to the power n. Is that okay? That's it. So once you have the binomial theorem, a lot of strange things, you can prove it to be correct. The next one is called Vandermon's identity. So let's take a look of this one. So you don't need to memorize the name, but when you see this, you should have somehow have some idea to prove it, why this is correct. So this is n plus m, choose r. So you have n plus m, choose r. We are saying that this is equal to, so this looks a very complicated formula. This is like summation, you have a new parameter k equal to 0 up to r. M times r minus k, and then n choose k. Wow. So you have some identity to be proven, but it looks very complicated. First of all, on the right hand side, this is not just one term. It is the summation of r terms. So this is difficult already. And also each term is a product of two binomial coefficients, two terms. And this makes it even more complicated. Okay. But on the left-hand side, it's so simple. It is n plus m choose r. So you will see that this must be talking about something like there are n plus m people, and then I want to choose r of them, right? And then how many ways are there? And then actually this gives you a hint, n plus m. So you should not look at all the people, there are n plus m people, but you may think of that as there are n boys and n girls, m girls. Is that okay? So people, you can divide it into two groups. So there are some boys. So there are let's say there are n of them, boys. And then there are m girls. So there are m girls. Is that okay? And then we are selecting r people from them. And we are selecting r of them. R of them. How many ways can we select? And then if you look at it, the right-hand side looks like what? The right-hand side is I'm selecting k boys here. So the right-hand side, there are summation. So you can think of this as it must be talking about different cases. Okay, it's the ways of doing everything in each case. So this is rule of sum. But for a particular case, n choose k means that I'm going to select k boys. And then m choose r minus k means that I'm going to select r minus k girls. That's it. Okay. This is how we can prove it. The number of ways to choose r people from n boys and n girls must be equal to the number of ways to choose k boys from n boys, and then multiply with the number of ways to choose r minus k from n girls, where k can be equal to 0, 1, 2, 3 up to r. Is that okay? That's it. Of course, we will need to be a little bit careful. So what if there's just one boy and then I want to select 5? So what is meant by 1 choose 5? So we may happen to have a value here greater than the value here. Am I correct? So if you encounter something like 1 choose 5, the bottom part is greater than the top part, you just treat it as 0, and that will be okay. Okay, it just says that there is no way to choose 5 boys from 1 boy. You just have 1 boy. How can you choose 5 of them? Okay, but all the other case, it is the natural combination term. Okay, so the number of ways to select r people, you can think of this as case 1, there are no boys. Case 2, there are 1 boy. Case 3, there are 2 boys, and so on and so forth. Is that okay? And for each case, how many ways are there? This is the number of ways that there are exactly k boys. So you have this is exactly k boys. You sum all of them for k equals to 0 up to r, and this is the answer. Okay? Now, so let's do the Pascal triangle again. Okay? And let's square each term. We make a square to each term. So we have 1, we still have 1, 1. We now have 1, 4, 1. Is that okay? And then we have 1, 9, 9, 1, 1, 16, 36, 16, 1. Is that okay? And we add them up together. We add them up. So this one you add it is 1. This one you add it is 2. Is that okay? This one you add it is 6. This one you add it is equal to what? Is 20. This one you add it is what? 70? Eh? Is it 70? Let me see. Looks like 70, right? Okay. Looks like, yeah. So what is special about this term? Let's compare this with 2 choose 1, 4 choose 2, 6 choose 3, and then 8 choose 4. So what is 2 choose 1? 2 choose 1 is 2. Is that okay? What is 4 choose 2? 6. Is that okay? What is 6 choose 3? 6 choose 3. 6, 5, 4, 3, 2, 1. So 3, 2 cancel with this one. So you get 20. Is that okay? And then what is 8 choose 4? 8 choose 4 is 8. You start from 8. You write down 4 numbers. 8, 7, 6, 5. Divided by 4 factorial. You start from 4. You write down 4 numbers. 4, 3, 2, 1. So 3 and 2 cancels with this 6. Is that okay? 4 and 8 cancels. You get a 2. 2 times 5 is 10. 10 times 7 is 70. So this gets 70. Is that okay? So it means that if you add the next term, you should have 10 choose 5. Is that okay? Is that okay? So in general, we want to prove this. We want to prove what? In general, we want to prove this. The summation of all the terms r is equal to 0 up to n, the square of n choose r is equal to 2n choose n. Is that okay? This is what we want to show. And let me give you a hint, okay? Hint, this is the hint. N choose r is equal to n choose n minus r. Yes? N choose r is equal to n choose n minus r. Yeah, that's it. So think about it. So two hints, okay? This is the first hint. The second one is something we just talked about. We have just talked about. Okay. So why is it true? Anyone? If you believe you get the answer or you get the idea, could you please raise your hand? I just want to have a look. Don't be shy. Good, excellent. Okay. So first of all, if you, I just can tell you, you can just simply apply this random Morse identity. If you don't remember this random Morse identity, you can start from scratch here. This is, you have 2n people altogether, you want to choose n people outside. And how many boys and how many girls are there? You can decide how many boys and how many girls. But to suit your problem, let's assume that there are n boys and n girls. Okay? There are a number of ways to choose n people. Out of 2n people, you must be choosing r boys and then n minus r girls in each case. That's it. The number of ways to choose r boys, exactly r boys, it must be n choose r times, you have to get the remaining from the girls, n choose n minus r. Is that okay? So if you realize that this term is equal to the summation of r choose 0, r is equal to 0 up to n choose r, n choose n minus r, that's it. You are choosing r boys and then n minus r girls. This is the number of ways. The total ways must be, you have 2n people altogether, you choose n of them. Because every way is selecting n of them. So this is 2n choose n. That's it. Okay? So to learn more, okay, about, okay, so in the exam, so this is important, okay, in the exam, some of the questions we will ask you to prove it by combinatorial arguments or the double counting method. And in that case, we don't give you any marks if you use algebra to prove it. You must create a certain kind of story, like there are n boys and n girls, and then you want to choose whatever, and then you are using separating this into cases, rule of sum gives you the answer. You will have full marks. Easy, you just need to write down more words. It's easy to think about it. On the other hand, if you use tedious derivation, if you use induction, you write down 3 pages, you will get 0 mark because we are asking you to do combinatorial arguments. And in that sense, we are hoping that you can master this technique. Is that okay? Okay, so let's take a break.